Good afternoon and welcome everyone. Thank you for joining us. My name is Ariel. I'm the sales manager of Starview International and will be your host and facilitator today. At the bottom of your screen, you should see a Zoom toolbar similar to what I have shown here. You may submit any question you have throughout the session, and we will answer them during the Q&A session. If you run into any difficulties, please let us know in the chat window and our panelists will assist you. Our agenda is as shown here. Our panelists of speakers today are Yu Zhu, Managing Director of Starview International, who will be sharing with you more about modernizing your IT infrastructure. Edwin, Director Global Sales of Highstack, who will speak with you on the migration to and between clouds. We also have our team of panelists from Starview, James, System Engineer, Chan, Consulting Systems Engineer, as well as Ray, Marketing Director. And also from Highstack, Julia, Head of Engineering. So without further ado, let me hand over to our first speaker, Zhu. Over to you, Zhu.
Thank you, Ariel. Let me set up my screen. All right, good afternoon to everyone who have joined us. I'd like to thank you for your time today. Today's seminar is the second in a series which we have organized. So in case if you have missed out on our first webinar, please visit our webpage. The URL shown at the bottom left of the screen here. Please go over there, and the recorded session of our first webinar is up there. The first webinar was about building a high-performance public cloud, which we call OneStack. Our public cloud solution is based on open source OpenStack, and it is a complete software and hardware stack. OpenStack and its derivatives has been widely deployed by the world's largest cloud provider, and we are now bringing you that same capabilities, that same flexibility that you are familiar with inside an infrastructure that you can own. Today's seminar is a partnership with Highstack, the leader in migrating your company's application from anywhere to anywhere. Specifically, we will show you how you can move your applications from your existing compute infrastructure, whether they are on bare metal, on another cloud platform, or a public cloud platform, onto a private cloud platform, which we call OneStack. For today's agenda, I will cover the following topics. First, I will introduce Starview, the company behind OneStack. Then I will define the legacy system and the typical challenges that a CIO would face every day. Then the benefits of cloud computing, followed by a comparison between a public and a private cloud. After which, I will do a very short introduction to OneStack, which is our private cloud solution stack. And after that, I will hand this webinar to Edwin from Highstack. So a little bit about Starview. Myself and Wilson Tan founded the company 11 years ago in 2010. When we first started, we had a single product, which was a programmable SFP. So a programmable SFP can be used in any brand of a network equipment. We had a patent on it, and following on, we expanded the business and transformed the business over the years and won numerous awards. Today, we are the experts in building a private cloud called OneStack, and our customers typically are governments, service providers, mobile operators, and large enterprises. So let's pause a moment here to reflect exactly what is a legacy system. This cartoon from Dilbert captures the consequences of falling behind because of the constraints of a legacy systems. So I'll pause here to allow you to take a brief look at this cartoon. So the message here is simply that systems will eventually become obsolete. And if you're not careful, you'll be on the wrong side, which is on the losing team. Having been in the IT career for more than 30 years, I've seen how computing systems have evolved from mainframes to minis to desktop computers. And now we are seeing a shift back to a centralized computing model. This shift happens because there was and still is a better, faster, and a cheaper way of doing things. There are so much advances in semiconductors, in the progression of the Moore's law, improved software, and so many other things that has evolved over many years. So today we can do things faster, cheaper, software are more reliable, and new methods and methodologies of developing software. More people are now connected and creating vast amounts of data and information. So all of this needs to be processed and needs to be stored somewhere. Systems that were built for an earlier era can no longer handle the shifts in usage pattern, can no longer be in silos. Systems must now be opened up, and data must be shared across applications. So how we use and how we consume data and information has put a lot of pressures on current systems. Today's current systems can no longer cope, and when it has hit its limitations, then it is outdated, and it's time to modernize the whole infrastructure. When we mention about legacy systems, there are actually two big categories. The first is hardware, and the second is software. Both needs to be updated, and it can be done in a phased approach. First, we can update the infrastructure while maintaining the current software. Then over time, you can update the software because infrastructure is now modernized to allow you to take advantage of the latest technologies. So let's look at some of the characteristics of an aging hardware. First, you have hardware that's probably old, maybe 5 years or older, and it has now become very uneconomical to maintain or to repair. Or it may not even be possible to repair because spare parts for it are no longer available. Things have become so expensive even for maintenance. And the frequency of breakdowns or failures are increasing, and you will probably spend a lot of time chasing down problems. And with that, loss in productivity. So for software, the issues you probably faced is the difficulty in sharing data across applications, and a possible workaround for that is perhaps to have multiple copies of the same data. Then you will have another problem. Which data is the correct one? You will also have support issues, probably because the old software provider has ceased support, or if this is an in-house software, you'll find that you cannot hire the right people anymore to update the code. Or perhaps the company may want to enter a new business. For example, to have an online marketplace, but the ERP system simply cannot handle it because it was not designed to do so in the first place. You are not alone actually in facing these challenges of a legacy system. And today, the unexpected has happened. We have been thrown a curveball, something that we do not see coming. And this COVID situation demands that we find a new way of working from home, for example, or working from anywhere remotely, except in the office. And is our system configured to do that? In a well-designed modern architecture, it is all about agility and resilience. Agility because we have the flexibility of adding or reducing capacity at ease. Modern architecture also means that system failures are always designed in mind. Systems should work around failures, self-heal, so that services continue to be delivered without interruption. With this capability, it will give us the ease of mind to be able to do repairs at a convenient time, rather than scheduling a maintenance window in the early morning, from midnight to early morning, for things to be updated or to be repaired. Modern architecture is now the cloud. Earlier, we talked about the shifts from mainframes to minis to desktop. Now we are seeing a shift to the cloud, back to a centralized model. Why? Because when things are centralized, it is easier to scale, it's easier to maintain, and more reliable. Along each of these shifts, we see new applications, a new way of doing things, which results in lower costs and higher productivity. This movement is relentless. Now we have applications such as Zoom, which places new demands on the infrastructures. We see mobile phones getting more powerful each year, and we see a new way of working remotely. We also see very large data sets being created, stored, and analyzed. For example, data lakes. All of these are happening and is pushing us to redesign and rethink the infrastructure. Cloud computing is the new modern architecture. This shift to cloud computing is actually very, very real. The world today is so different. New applications are being developed, more data and information is being generated from millions of connected devices. We see new threats coming from unknown actors and with ransomware. To deal with this, companies have used public clouds, and many applications have moved over. That is why we see companies such as AWS, Microsoft Azure, Google, etc., have grown so big and have also become the largest trillion-dollar companies today. The benefits of cloud computing are very compelling. It gives us so much flexibility in terms of compute resources, short turnaround in rolling out new applications and services, and new ways of engaging with customers with full control and audit. So the conclusion is that the cost of not moving to the cloud is now too high to ignore. So what does it mean by moving to the cloud? Does it mean moving to a public cloud like AWS? Well, the answer is it depends, because there is an option to build and own a private cloud. A private cloud that offers the same flexibility as the public cloud, with all the advantages of having it private instead of being shared. So for example, you may be in a highly regulated industry, like a bank, for example, which may mean that certain data cannot be stored in a public cloud. Or your use of a public cloud has now become so expensive because because of the number of workloads that is currently being supported. So now, because it is so expensive, it makes sense to build one instead. You want to have the full flexibility to operate the cloud according to what your company needs and not what the public cloud can deliver and impose on you. Okay, so now you want a private cloud. Where do you start? OneStack is a full private cloud solution stack. It is a fully integrated cloud software in a very high performance compute cluster. OneStack is based on OpenStack, the world's leading open source project for the cloud. OpenStack and its derivatives are widely used by the large cloud providers. So there is no question whether it works or its ability to scale. OneStack is a solution stack comprising of compute, network, and storage in a fully virtualized environment. Software is license-free. Compute, network, and storage hardware are fully bare metal, so you do not pay a high price just for a brand. Everything in OneStack just works because Starview has selected the best combination of hardware and software to make deployment easy and fast. This is a logical diagram of OneStack. All workloads runs in virtual machines where the resources of compute, network, and storage are software defined. If any of these resources are insufficient to support the applications, then we can redefine and reprovision. We can allocate resources easily to respond to growth. Because everything is software defined, addition of new nodes of compute, network, or storage scales the capacity linearly without bringing anything offline for upgrades, updates, or maintenance. Everything are done in service with zero disruption. Best of all, you do not get a price shock because the cloud software is open source. Hardware is bare metal. And instead of annual support licenses, you pay for annual support. The process of modernization or moving to a private cloud is simplified with OneStack. Starview has done the hard work for you to design and build the private cloud. You start with the right size of infrastructure for your needs today and add more as you grow. We have designed the systems with failures in mind so that there is automatic workaround in failures. Self-healing happen with zero interruptions to services. we make sure that the entire infrastructure is maintained and run at the optimum. Highstack is our partner that we work closely to help you migrate your workload and data to one stack. Highstack's other capabilities are in backup and disaster recovery, or if you are using public clouds today, Highstack's FinOps gives you the visibility to your public cloud usage so that you know what you're paying for and let you fine-tune your cloud usage to optimize your spending in the public cloud. In ending, these are some of the companies that we work with to make OneStack a full private cloud solution. So with this, I would like to hand over to Ariel and for Edwin to continue with this webinar.
Thank you, Ju. I see that we have a question, and I would like to remind everyone that you may submit any questions anytime throughout the session. Now, may I invite Edwin from Highstack? Edwin, please.
Oh, Ariel, hello. Thank you for giving the mic to me, so to say. So thanks also to everyone who's joining the webinar. Thanks a lot for your attention and time. So let me tell you something about Highstacks. So first, let me recap a little bit what the show said. So regarding the importance of the cloud, this is really 100% true. So cloud is nothing new, of course. They've been around for a while already now, but they're not evenly distributed. While here in Frankfurt, Germany, where I'm located, Amazon was already like 6 years ago. In Saudi Arabia, in South Africa, they just arrived last year. So there are still some places on the planet which are not, where's not the availability of the hyperscalers, but this is just a matter of time. So the question is not if you're going to use clouds, of course you will. The question is what kind of clouds, how many, and as Joe said, the advantage of a private cloud is for sure that you have the ownership, the flexibility, and also on a cost perspective, OpenStack, open source, of course, makes sense because the big hyperscalers, which are for Google, Amazon, Microsoft, Azure, and Alibaba, they are not always cheap. So people want to move to the cloud in order to save on the costs, very often get surprised. But this is what Joe mentioned. Highstacks is not only going to help you to move into the cloud with the migration, we also have a way to support you once you're in the cloud to use it in the best and most affordable way, showing you how to save money, how to optimize the resources by downsizing, optimization recommendations, and installing a process which is called FinOps, which is the evolution of cloud cost management. It's not just some sporadic actions like downsizing some machines or deleting some images to save some bugs, but it's a process. It's a process where IT guys and finance guys together have an understanding, best practices, are trained how to use the cloud in the most affordable way. This is the part IT budget control, as you can see here, also test environment management. So Highstacks offers quite a lot. But today we focus mainly on the live cloud migration, because before you can benefit from all these nice other products, you first have to be there in the cloud. So how to do this? How do we move you into the cloud? Our mission is make the journey into the cloud a simple and straightforward process. So now you're on-prem or maybe in another cloud and you want to go to Starview OpenStack cloud, the promised land, and we help you. We bring you from one place to another. That's the name of the game. Sakura is the product for this. So Highstacks is a software company. We have two solutions. One, scale, is about all this cloud cost savings, optimization, which is another topic, but for today. So, and here you can see the two products, OptScale and Accura. Accura is the software which is dedicated for only use cases. One is live cloud migration, the other one is disaster recovery. It's a similar flow. This is why we have one software for both use cases, because both is about getting the data from one side to the other. Let's talk about Accura. As said, a software which covers two use cases. One is live cloud migration, the other one is disaster recovery. What is good to know is that it's a simple and automated way. So if you talk about migration, you can also do it manually, and this will be fine if you have just 1 or 2 or 20 machines. But if you have a couple of 50, 100, or even 1,000 machines, believe me, you don't want to do it manually. You need it as automated as possible. So if you talk about our migration solution, of course, we talk about a fully automated process. And this process is called lift and shift, by the way. So what we do is we replicate the whole machine as such, either virtual machine or physical servers. So please note, we can also migrate bare metal machines, physical servers, not just virtual machines. There are different ways of doing migration, like replatforming, rehosting. Lift and shift is considered to be the simplest, easiest, and less cost-effective way. It's migrating the whole machine with all the data running on it or attached to it. And this is done by the so-called incremental replication. So we replicate the data. First, we take a full copy, and then we take incrementals. This is called lift and shift. A one-touch DR and migration, highly automated orchestration. As said, automation is key, and it really runs smoothly, quickly, and efficiently. This is the aim, the name of the game. What is important to know is that we support more platforms than anyone else. So here you can see on the source side, these are just examples. We like to emphasize that we also do, as I already said, physical servers, bare metal machines, Hyper-V, other clouds, OpenStack, KVM, no matter what. You can think of all the names which are here also on the left side, IBM Cloud, Tencent Cloud, whatsoever. The source is always a given because we just need to deploy our agents, which is either a Windows or Linux machine, and there are no exceptions. We only a few, like physical servers, Solaris machines are not supported, for example. There are really few exceptions only. On the target platform, we are integrated in those platforms which you can see here right now. So all the big hyperscalers and KVM and OpenStack-based platforms. So this is where we come together with Starview because it's open source, OpenStack. So the use case, if you want to move to Starview, is covered. And as you can see here already, our software solution, HiSeX Accura, is part of the target platform. So don't be afraid that you're connected to a third-party company from the United States. You don't know us. What do we do with the data? We don't process, we don't even see the data because it's just a software which we give to our partner. They run it in their own OpenStack cloud. And so there's no connection to HiSeX. It's just source and a target platform. That's all. Let's have a look at the migration process. What is good to know is that, of course, all this replication, what I mentioned, the incremental replication, happens in the background. So there's no interruption of the business, of operations. There's no downtime, no impact on the bandwidth. Everything happens in the background. First, we take a full copy and then just the incrementals, the changes between different snapshots. We can use internal or external agents. So if the source is VMware, OpenStack, we can do even agentless migration without deploying agents. Anyhow, it's not a big difference for the flow itself. There's no downtime during this process, and you can run as many test migrations as you like. This is very simplified stages of a successful migration. So first we have to identify the workloads and see what do you want to migrate, what can be migrated, are the operation systems supported, what are the dependencies among between the machines, and so forth. This helps us to create a migration plan. And then also we have to recreate parts of the network setting before we can do the migration, because as said, HiStacks replicates all the data and the metadata of the machines, so also IP addresses, MAC addresses, subnets. But what we cannot migrate are things like firewalls or VPNs. Those we need to recreate first on the target side, and then we run the test migrations, and finally plan and execute the final migration. That's the beauty of a migration. Of course, you can plan it, you can schedule the final cutover, which is the opposite to a disaster use case where you don't know when it's going to happen. The final cutover, in this case, this is the only situation where we have downtime, where we need a maintenance window, but don't worry, because it will be a very small maintenance windows. First, it's predictable, so it won't be a surprise. We can tell you exactly that you need 1 hour or 2.5 hours, because we do test migrations, and the final migration is exactly the same scenario like during the test migrations. So we know how long the downtime will take, and we can easily migrate several hundreds machines in a single hour. So only when the cutover is done, we pull the very last incremental, the last snapshot, and then we boot up the machines. That's all. Here you can see the flow for OpenStack-based clouds. As you know, Starview OneStack is based on OpenStack and open source. And this is the flow. As I already mentioned, HiStacks Akura, which is actually a set of Docker containers orchestrated via Kubernetes. It's a software which is running inside the target cloud. There are just two parts: the customer with the source environment where he is now on-prem, for example, and the promised land OpenStack cloud. And there our solution is an instance running in the target cloud already. And from this instance, which is a small virtual machine, there's a UI where you download the agent. The agent is deployed on the source machine or on the hypervisor level. There are different ways to do it. Here, for simplicity, we have just one machine, but it could be 50 or 5,000 machines. It doesn't matter. The agent detects all the machines around him and automatically creates a connection with the HiStacks controller running in the target cloud. And via this connection, HTTPS, we send encrypted the snapshots. Receiver receives them, and then we store the snapshots in volumes. We always take consistent snapshots, of course. On Windows, we get so-called application consistent snapshots, and on Linux, crash consistent snapshots. And then when we do the cutover, we do this in an orchestrated way and call first for the V2V, to virtual or physical transformation, where we then change IP addresses, resource flavors, CPU, we can change the disk size. Everything is possible during the cutover. The orchestrated way means that, of course, we boot the machines in a certain order. So first, for example, Windows Active Directory, then the machine with Oracle databases. Next step would be moving the clients to those databases. This is so-called orchestrated launch. And of course, we support it. So very simple process, a solution running in OpenStack Cloud. Agents get downloaded, deployed on the source machines. Agents make snapshots, send the data over to the target cloud. There we store them in volumes. And then when we do the cutover, we boot the machines directly from those volumes. That's it. And it's the same, actually, flow for the, it's the same flow for disaster recovery. Disaster recovery is also recommendable. So if you don't dare doing the step to the OpenStack cloud for your all your production servers right now, you still want to stay on-prem, at least start using the cloud for disaster recovery purposes. That's very nice, because if you have, like now, a very traditional disaster recovery setup, you have this, let's say, a copy literally of your production site on the other side, on the DR side, and there then you use VMware Site Recovery Manager or other solutions for the failover, which means that you have to pay all the licenses twice, for VMware. You have to pay for all the CPU and power all the time if there's a disaster or not. It's much, much smarter to use an OpenStack cloud for disaster recovery, and then have no vendor login, which is the specialty of VMware, by the way, not paying any licenses twice, and not paying for CPU, not paying for power, just for the storage, because we take the snapshots, store them already on the other side, and only when you then have the disaster, and we do the failover, then boot the machines in the OpenStack cloud, and then the machines get created and cause, of course, consumption. So with HiSec Sakura in the disaster recovery field, you can use it for full disaster recovery as a service. You can use it for private and public clouds. And also, of course, we offer cloud backup. The advantages are no vendor login, cross-cloud disaster recovery, migration from any platform to any platform. Full DR automation is not just an automated failover. It also means when you want to go back, fail back, this should also be fully automated, of course. And our RPO and our RTOs, recovery point objective and recovery time objective, are just minutes or seconds, very good ones. Last slide, let me show you some customers we work with. So we have a strong presence in telcos because they all use OpenStack clouds. And since HiSec is naturally born in OpenStack, the first clouds we supported was Canonical, OpenStack, Red Hat, and then other distributions. So we are really the experts for OpenStack. This is why you find us in a lot of communication companies, integrators like us, outsource providers. Here we have our partner Starview. They use us to bring onboard their customers. And also due to our OpenStack background, we have a presence and partnership with those vendors, as you can see. Last but not least, a case study where we did a migration for a company in Middle East, in the Emirates, Dragon Sky International, a big water and power company. They had also asked to migrate from VMware in a local data center to OpenStack. And actually, the situation was that we had just 2 weeks time. They had only 17 machines, which is not too much, but the internet connection was just 4 megabits per second, which is really not a lot. And so the replication took a while because they had in total 3 terabytes, and replicating 3 terabytes via a bandwidth connection of only 4 megabits per second was quite challenging, but we did it all together in 2 weeks time, and finally booted the machines, migrated them to OpenStack. You see the workloads, Active Directory, Exchange servers, Oracle DB. So from a workload perspective, we have no limitations as well. We are so-called application agnostic. Whatever you want to migrate, if it's SAP, HANA, SAP HANA, or Kubernetes, or Exchange servers, or Oracle databases, we can migrate it all because, as said, our way to migrate is lift and shift. So we replicate the whole machine, no matter what applications are running on it. That's it. Thank you very much for your time and attention. And now I hand over back to Ariel.
Thank you, Edwin. Thank you very much once again to Ju and Edwin for your presentation on OneStack and HiSec. So we shall now proceed with the Q&A session. Let's take a look. For the first question, what potential savings will we be looking at if we modernize using OneStack? I believe, Ju, would you like to answer this question?
Okay, allow me to take this question. When we look at potential spending on private cloud, the major components are these: the hardware, the software licenses, professional services, and ongoing support. So by using OneStack, a major portion of the CapEx, which is the software licenses, that portion is the savings. Because in a typical private cloud deployment, commercial software licenses can easily take at least 50% of the spending. And it's actually very expensive considering that it's just software. So if we use OpenStack and it is license free, it is open source, you don't pay for it actually. So that is the major savings that you can have if your decision is to deploy an infrastructure based on OpenStack rather than an equivalent commercial software. So the savings can be substantial.
Thank you, Drew. Hope that answers your question. And we have a few questions for HiStack. The first question would be, how long does it take to perform a complete migration? Edwin and Julia, would you like to take this question?
Yeah, so this is depending on the amount of data. So the biggest time-consuming part of the whole migration process, first of all, is the pre-assessment of the workloads, talking to the business owners, and so all these talks, if you consider this as well, the project might take maybe months, but the real migration is just the replication of the data and then the cutover. And the replication of the data is only dependent, it's pure mathematics, on two factors. One is the bandwidth available, and the other one is the amount of data. And this is out of our influence, so the higher the bandwidth, the better, of course. And then the final cutover, as said, we can easily migrate several hundred machines in 1 hour. So it all depends on the amount of data and how long we need to replicate it. That's it.
Sure, thank you. And next, there's a question regarding bare metal migration. So I guess maybe you would like to elaborate more about this bare metal migration.
So bare metal migration is just, it's the same migration, it's just that the source would be physical servers. So we don't migrate from bare metal to another bare metal machine. This we don't. It's cloud migration what we offer. So the migration destination platform will always be a cloud. It can be either a hyper public cloud, a private cloud, but of course it's cloud migration. But the source machine does not have to be a virtual machine. So we are also able to work with physical servers on the source side. That's what we mean with bare metal server.
Thank you. Hope that answers the question. And okay, next, is lift and shift similar to drag and drop function on our computer?
No, this is just, it sounds similar, but the drag and drop is just on your user interface, how you move some numbers from one field to another. But lift and shift, because it sounds like it's like a picture. Of course, no one really takes the whole machine and carries it somewhere. But it means that we don't do just make migration of application or on the file level of whatever layer. It's really that we literally or virtually take the whole machine and as it is and replicate it. This is why I call it lift and shift, but this is just the expression for it.
And then, so is there any limitations to the number of virtual machines storage that can be migrated in one time?
I don't think there are. I think this is a nice question for Julia, so that you don't feel asleep, Julia. Would you mind answering?
Yeah, sure. From the product point of view, there are no limitations. So here we depend only on the amount of data you want to replicate. If you want to replicate 10 terabytes of data, feel free.
So the short answer is there's no limitation at all.
No limitation at all.
Okay, great. And then next, there's one question that many companies now have current infrastructure. So does our bare metal private cloud support to using current hardware like current server? This will help those companies save costs and easy to approach our solution. Perhaps this question, perhaps Drew and Edwin would like to.
Yeah, let me take this question. I think this question is for us for the OneStack. So maybe what this question means is whether the customer can use their existing hardware, their existing servers that they have, and just use that software that we have, our distribution of the OpenStack. And will we support such an implementation? So the answer is yes, because the software is designed to run on any server hardware, as long as the configuration and as long as the memory requirements and as long as the CPU, storage, etc. meets the specifications. However, that process of selecting the correct combination of hardware, the different configurations of hardware in order to run OpenStack optimally and to provide the kind of performance for enterprise customers is very, very complex, because we have to build a balanced system. A balanced system means that you cannot mix a fast component paired with another slow component. The entire performance of the system will be the lowest denominator. It will run very, very slow. So that is why in OneStack, we have purposely put it together as a complete solution, software combined with hardware. And we have purposely chosen the hardware that can, with the combination of configuration that can run optimally with OpenStack. And the other reason is that support cost is dependent on the number of nodes, physical nodes, that will eventually be running in the entire infrastructure. So our preference is to use very, very high performance machine in order to reduce the number of nodes, hence reducing the amount of support costs that the customer will pay over time. So if the customers has current hardware that they would like to reuse, and if these are not high performance machines, it will result in very, very inefficient infrastructure, and which will cost a lot of money to run and support over a long term. So the answer is both yes and no. Yes, of course, the software can run on top of it. No, because it's not recommended, because we are not extracting the best performance, nor we are reducing costs over a long term.
Sure. Hope that answers your question. And next, is HiStack a one-time usage migration solution?
Yes, it's a one-time business by default migration. You are now somewhere else. You want to go to the promised land, OneStack, OpenStack Cloud. We bring you there, and when you arrived, you can just forget about us.
And perhaps we can answer this question first. It is also for HiStack. Can HiStack be used with external storage solutions? Would you, Julia, like to answer this question?
I suppose this question is related to OneStack now, because our solution is not open source.
No, the
HiStack, can HiStack be used with external storage solutions?
Sorry, no, because we don't have any storage or cloud ourselves. We provide a solution that the customers may use to migrate to another clouds.
Let me add on to this, because the external storage is supported by OneStack, because OneStack can interface with external storage that are not part of OneStack. So if the applications runs on with data that lives in external storage, HiStack actually do not care where the data lives. So yes. The answer is yes.
Yes. And following on with OneStack, this question is related to security. How would the security aspects in terms of patches and compliance be addressed? Since the platform is open source, knowing that cyber and security threats are a big thing nowadays. So
let me take this question. Vulnerabilities, threats, etc. do not care whether the software is open source or closed source. Threats happen everywhere. In fact, the highest incident of threats happen in closed source software. For example, like Microsoft, right? So by having it on open source doesn't mean that we are more vulnerable. On the contrary, because it is open source, there are a lot more developers around it which respond to the threats faster with patches. So we do not fix those patches because these patches are developed by the community, by the open source community. We will just have to make a decision of which patches are relevant, and then schedule a maintenance to update the software. Perhaps Chan or James, would you like to add on if you have other views?
James here. I want like to add that this our one stack is actually based on microservices, and it is run in terms of containers. So in terms of patching and compliance, if there's any issue and we need to do the patching, we just have to touch individuals' containers to update that particular microservices. So it's quite a straightforward thing.
Chan, would you like to add on to the answer?
Yeah, I think for open source, one stack have been used by a lot of big companies. So on the security issue patches, actually, if necessary, we can always work with our teams will work with the individual customer to address their issue. So yeah, this is okay.
And like I've always said, OneStack, OpenStack, and the derivatives of OpenStack is deployed by the world's largest cloud providers. So it definitely works, and it definitely scales to very, very, very large cloud.
Hope that answers your question and clarifies your concern.
Ariel, there's one more actually in the chat window.
Oh, okay. Sorry, I might have
let me
missed
read
it
up.
out. Okay.
I think it's from William. The question is adding on to the open source questions posted earlier. If there's any security vulnerabilities or bugs discovered, can we still meet the customer's stringent SLA for patch management?
This is a tough, very, very tough questions. Because SLA for patches, for fixes on software bugs, etc., is non-guaranteed. Even the largest software company, Microsoft, whatever, when a vulnerability is discovered, there is no guarantee that the software can be fixed within a predefined window. So I guess that this is an industry-wide problem with no solution, whether it is open or whether it is closed source. But what many companies have done is that whenever any vulnerabilities are detected, it's first reported secretly, then the patches and fixes are developed, rolled out, then the announcement is made on the vulnerabilities. So that's how the industry has handled such software defects.
Is there anything that James and Chan would like to share with regards to this question?
I believe as part of this patch management, typically what the industry do is that the availability of the patch comes from the vendor or from the open source community. But once the patch or the whatever bug discovered, the patch is available, there is still a need to verify that the patch works. Okay, so typically there will be the customer will set up some test bed where they will verify that the patch actually works and it doesn't cause any other ramifications for the existing production system. It just because the patch is available doesn't mean that it will work, because it could be rushed out, and you really need to test it out in your production environment. And typically the customers, the enterprises would set up a test bed kind of to mimic the production in a small setup and to test out all these patches. So these are the things that the customer would do to verify the patch actually works before they actually apply it. Yeah, that's what I have to add. Thanks.
Thank you. Hope that answers your question, William. Okay, so if there are no more questions, we would like to thank you once again for joining us today. We have come to the end of our webinar, and we hope that it has been a good use of your time today. Do follow us on our OneStack page on LinkedIn to keep up-to-date products and solution news and update on OneStack. So our LinkedIn page is just called OneStack. And once the recording of the webinar is available, we will inform you. Please help us complete the survey at the end of this webinar. Thank you. And with that, we wish everyone a pleasant evening ahead. We will now end the webinar. Thank you and goodbye.
Thank you.
Thank you, everyone.
Bye-bye.
Thank
Bye.
you.
Bye.
Welcome.